Hello friends, welcome to another lecture number 2 of vector calculus and of mathematical physics for MSc and BSc students. So here we're going to discuss about three topics. One is scalar product of vectors, polar coordinates and rotation of coordinates, right? And link of the previous lecture is given in the description box. So please watch that video for better understanding first. So now let us start, and before I start, please like, share and subscribe the channel if you are new to my channel, and if you think my videos are helpful, please share with your friends. Okay, so now let's start. So our first topic is scalar product or dot product of two vectors. Suppose let us have two vectors. This is vector A and vector B. Angle between them is theta. Now vector A dot vector B, their dot product is given by magnitude of vector A, magnitude of vector B cos theta, right? So here you can see this B cos theta represents the projection of vector B along vector A, right? So if you draw a perpendicular here, this and if you name it right, OAB, and from this triangle you can see cos theta, that is based by hypotenuse, that is OB by OA we will get, and so OB will be equal to OA cos theta. So this OA represents nothing but length of this vector B, okay, length of the vector B, right? So this is called projection of vector B along A. Now A can be written as magnitude of vector, sorry, OA is replaced by magnitude of vector B, length of vector B, so cos theta. So this is the projection OB, right? So let me take this as the terminal point C, right, of this vector A. So length of vector A will be given by OC dot the projection OB. This is the projection OB. So let me write OB. So OC is the length of vector A and OB is the projection of vector B along vector A. So hope you have understood. This is the dot product and meaning of dot product. So now our next topic is polar coordinates. Let us start that. So polar coordinates. Suppose this is the coordinate system, three-dimensional coordinate system. So this is origin. Here is a point P with coordinates x, y, z. So and these are the three axes x, y, z, right? So now let me draw the projection. Sorry, this is the position vector. OP is the position vector, vector R represented by vector R, and projection of vector R over the along the on the xy plane, that is the OQ. OQ is the projection of this vector, and let us draw a perpendicular on OQ. So this is 90 degree here, you see, and let me draw perpendiculars from P to Z axis, that is PR, and from Q to X axis, that is QS, and from Q to Y axis, that is QT, right? So here you can see this angle is suppose theta. Angle between the projection and the X axis is theta, and angle between the position vector and the Z axis is suppose alpha. So let me write what we have considered, okay, in the diagram. So you can pause the video to note all these things. So let me write. I'm playing this faster, okay, to save time. Right, now you see, so what are the perpendiculars we have drawn? Here you can see as the coordinates of P is x, y, z, so this length QS must be just wait, this length OS must be x, right? This OS must be x, and QS must be y, and OR must be z, right? So yeah, these are the perpendiculars we have drawn. OS is x, QS is y, then PQ is equal to OR. So here you can see these two sides. You can see this is a rectangle, okay. It's difficult to draw 3D figure in a 2D plane, so it's though it doesn't seem to be a rectangle, but it is a rectangle. This OQPR, this is a rectangle. So let me show it here. So this is in this shape, OQPR, right? So here OR and PQ, these are opposite sides of a rectangle, they must be equal. This, so OS is X, this is OT is, and QS is Y, and this one here you can see, this is Y, QS is Y, that's going to be equal to OT, right? That's why it is Y. Then here you can see this OR is Z, so PQ will be Z. Okay, so this is Z. Now angle between this projection and the x-axis is theta, we have considered. So SOQ is theta, right? And this angle that between the position vector and the z-axis is alpha, so we can write POR is alpha. So let me redraw the diagram. Let me draw it again on this slide. Okay, so that one slide was not enough for whole thing, so let me draw it again. So this is the diagram we have drawn in the previous slide, right? So right, so now you see, so let us take the triangle OQS. If you take this triangle OQS and this triangle, so here S is the right angle, this triangle we have taken, right? So this is O, this is Q, this is OQS triangle, and here theta is this angle SOQ is theta, so, and SQ is S and OS is X, right? So here you see, from this triangle you can find cos theta, right? This is OS is base, OQ is hypotenuse, so base by hypotenuse is the cos theta, right? So let me draw it properly. So this is theta, this is 90 here, B, and this is P and H. Okay, so this is the perpendicular, and this is the base, and this is the hypotenuse. So right here you can see cos theta is base by hypotenuse, so we can write OS by OQ, right? So here you can see this is OS by OQ, and this OS is, length of OS is X, so let me replace it by X. Then X will be equal to, this equation implies X equal to OQ cos theta. This is equation number 1, suppose, right? This is equation number 1. Similarly, we can take sin theta, that will be perpendicular by hypotenuse, right? Perpendicular by hypotenuse. So SQ is the perpendicular, hypotenuse is OQ, so QS OQ. So QS is length of QS is Y, so Y by OQ we will get. So it implies Y is equal to OQ sin theta. That's equation number 2. So now in the triangle OPR, so let me try to take this triangle OPR. So here perpendicular base hypotenuse, so this is the perpendicular base and hypotenuse. So OPR, so if you find sin alpha here, this angle is alpha, na? So sin alpha, so that's why perpendicular by hypotenuse PR by OP. So you can see the diagram. If you see the diagram, that OP is the position vector, so its length is R, and this vector is R, then PR. So here what we're gonna have, PR is equal to the projection OQ, right? PR is equal to projection OQ here. So PR is replaced by OQ, so OQ can be written as this R sin alpha, right? This is suppose equation number 3. So now cos alpha base by hypotenuse, so OR by OP, so OR is here Z, so Z by R, so Z will be equal to R cos alpha. This is equation number 4. Now we're going to use this equation number 3 in 1 and 2. So we're going to replace OQ by R sin alpha, this value. So hope you have understood this. So let me rewrite these 4 equations here also again. Okay, these are the 4 equations we have obtained in the previous slide. So if you want to note, then pause the video and note. Okay, so these are the 4 equations we have got. So now let me use 3 in 1 and 2. If you use that, in 1 and 2, then you will get x is equal to r sine alpha cos theta, then y is equal to r sine alpha cos sine theta, and z remains same here, right? So these are the polar coordinates of the point P, whose Cartesian coordinates here you have got x, y, z, right? So these are the polar coordinates that we wanted to obtain. And our next topic is rotation of axis. Okay, so let me take the same condition, the point P in the space, right? So this is the point P with coordinate x, y, z. So let me draw the diagram again, same as we have drawn in the previous slide. Okay, so all the things we have taken are same here. So now topic is rotation of axis, right? So let me write what we have considered here. So these things are similar, so you can pause the video to note, right? Now wait, so these things are same that we have written in the previous slide, in the previous topic we have discussed. So all the things are same, that all consideration that we have taken here, all the figures. So here again, let me draw the figure again. So here you see, so in polar form, that we have already discussed the topic. In polar form, x coordinate is given by r sine alpha cos theta, y is given by r sine alpha sine theta, then these two are equation 1 and 2 respectively, and z is r cos alpha, that is equation number 3. Now let us consider that ox is being rotated at ox and oy. You can let me consider that this system of coordinate is being rotated about z axis through an angle. Suppose this is y axis, now this is x axis. So x dash and y dash are the new system of coordinates. This x and y is rotated to these two positions, x dash and y dash, through an angle, suppose phi, right? So here you can see the new positions of x and y axis represented by x dash and y dash, right? So this angle will be theta minus phi, as we have taken this angle is theta, so this whole angle is theta we have taken, right? So now let us write what we have considered. Let the coordinate system be rotated about z axis. That means z axis is fixed, it is not rotated, but this x and y axis are rotated along the through the angle phi. The coordinates of the point P in the new system will be what? X dash, y dash, z dash. Suppose we have considered that way, such that z and z dash coincide. Okay, it remains same. Then now you see angle between ox dash and oq, ox dash and oq. Here you can see this is ox dash, this is ox dash, new coordinate, and oq. This angle is now theta minus phi, right? Theta minus phi. So here you see, to obtain the polar form of this new coordinates, what we can do, we can replace this theta by theta minus phi, right? In the previous case we have taken theta because this, here you see, if you draw, then x, this is suppose y. So let me consider the previous case. So here you see, this was the projection. Suppose this is the angle point P, and this is the position vector r, and position this projection was OQ, and angle between this projection on xy plane and the x-axis was theta. That's why we had taken here theta, right? You can see in equation number 1, 2, right? That's why we had taken theta. Now the angle between the projection OQ, you can see this angle between the projection and the new x-axis is what? Theta minus phi. That's why we're gonna replace the theta, where we have got theta in equation 1, 2 and 3. We're gonna replace them by theta minus phi, then we will get new set of polar coordinates, right? So doing that, we will get this. Okay, so now here we're going to apply cos theta minus phi formula, cos A minus B formula. If you apply that and then simplify, what you will get, we're going to get this result. So here you can see this r sine alpha cos theta. Let me rewrite again. Okay, here you can see this is r sine theta, sine alpha cos theta. That is what? That is x, right? That is x. Okay, so we're gonna replace this part by x, and we're gonna replace this part by y, because r sine alpha sine theta is nothing but y, using equation number 1 and 2. So using 1 and 2, right? So hope you have understood. So let me write the three equations in the next slide also, because there is not enough space here. So then we're gonna obtain the y dash and z dash also in the next slide. So let me go to the next slide. So here you see this is the x dash that let me rewrite it, and these are the three equations that we are using, right? Equation. So these are the polar form in the initial system of coordinates that we have taken. So y dash will be equal to sine alpha. Here you will see this theta is replaced by theta minus phi. So here let us apply here sine A minus B formula. Then what you will get, you're gonna get this. So applying sine A minus B formula. So here you can see these two parts, r sine alpha sine theta is nothing but this y, and this r sine alpha cos theta is x, right? So from 1 and 2 we have got this. So using 1 and 2, so we have used here equation number 1 and 2, right? You can see clearly this part is your x, right? If you compare with this equation number 2, and if you see this part is nothing but x, this is from equation number 1, you will get this one, right? So we have put here y and we have put here x, so we have got y dash is equal to this one, right? So hope you have understood this. So now z remains same. Z will be equal to z dash, that is r cos alpha, right? So here just let me write it properly. Okay, using equation number 1 and 2. So this is as z is fixed. Okay, here z is fixed. So these are the coordinates, polar coordinates of the point P, x dash, y dash, z dash, after the system is being rotated. After the system is rotated through an angle phi, right? So we're gonna write these things. Let me write the matrix equation of rotation of axis about z. That's gonna be equal to this. That's gonna be the x dash, y dash, z dash here, and this is the matrix, transformation matrix, you can say, right? And this is x, y, z, older set of coordinates, right? So that's how we can represent. This is the metric equation of for the rotation of axis about z axis. So hope you have understood this. So in the next topic we're gonna discuss the properties of vectors under rotation. Okay, what are the properties of vectors under rotation? We're gonna get the magnitude of vector is invariance under rotation, scalar product is invariance under rotation. So we can discuss those things, okay, in the next video. So hope you have understood this, and if you think this is helpful for you, that then please share this video with your friends, and subscribe the channel, like the video, also hit the thumbs up button, so inspire me to create new videos for you. So thank you for watching, and see you in the next video. Thank you.